In this video we're going to talk about work with real numbers. So work with the real numbers. So there are kind of 10 properties that we're going to go over through this. For all of these properties we're going to have A, B, and C are real numbers. So we're going to have A, B, and C are real numbers. Or we can say that A, B, and C are in the real numbers. The first property that we're going to use is the reflexive property. What the reflexive property says is that A is equal to itself. So any number is going to be equal to itself. That's the reflexive property. You can think about it kind of like a reflection. So if you look in the mirror, that's exactly who you see as yourself. So A is always going to be equal to A. Second one is the symmetric property. What the symmetric property says is that if A is equal to B, then B is equal to A. So if I have two numbers that are the same, then I can flip them across and say that, actually, I can say that B is equal to A. Third one is the transitive property. What the transitive property says is that if A is equal to B and B is equal to C, so I have two numbers that are the same, then these two numbers are the same, but both are equal to B, then in fact A is equal to C. So that's your transitive property. Fourth property is the substitution. What this says is that if A is equal to B, you can substitute B for A in any expression. So if you know that two things are equal, you can substitute them wherever you want. In the English language, it's kind of like saying, if you were a girl and your name was Mary, your dad would probably refer to you as his daughter or Mary, but they're both equal. He could substitute those in any sentence and people would know what he was talking about. So as long as you have that two things are equal, you can substitute one for the other. So that's the substitution. Next we have commutative. So there are actually two commutative properties, one for addition, one for one for multiplication. This says that A plus B is the same thing as B plus A. So it doesn't matter the order in which I add things. So for example, 2 plus 4, that's 6. That's the same as 4 plus 2. Doesn't matter which way you do things. Multiplication. A times B is the same as B times A. So it doesn't matter the order in which you multiply. So 2 times 4, that's 8. That's the same as 4 times 2. So commutativity means that I could move them around. 6, we can talk about the associative property. And again, there's going to be one for addition, one for multiplication. So the associative property for addition says that A plus B plus C is the same as A plus B plus C. The way you can think about this is it means that if I'm trying to add 1 plus 2 plus 3, I can either add the 1 and the 2 first and get 3 plus 3, which is 6, or I can add the 2 and the 3 first and get 5. Doesn't matter which way you do it because of associativity. Multiplication says that A times B plus C is the same as A times B times C. So again, if I'm trying to multiply 1 times 2 times 3, I could either say this is 1 times 6, which is 6, or I could say this is 2 times 3, because of the 1 times 2, which is again 6. So associativity tells you that it doesn't matter the order in which you add or multiply. The seventh property is distribution. So this is the distributive property. This is how multiplication and addition work together. So there are two of them. It says that A times B plus C is AB plus AC. It also says that A plus B times C is AC plus BC. So it's every time I have multiplication times addition, I just kind of distribute to both of my terms. So for example, let's say I want to do 2 times 4 plus 3. If I want to distribute this, I would first distribute the 2 times 4, which is 8. Then I would distribute the 2 times 3, which is 6. That would give me 14. Or let's say I want to do 1 plus 3 times 4. I could distribute the 4 to the 1, 4 times 1 is 4, then distribute the 4 to the 3, which is 12, and get 16. Now alternately you could have done 4 plus 3, which is 7, 7 times 2 is 14, or you could have done 1 plus 3 is 4, 4 times 4 is 16. It doesn't matter. This is just showing you how the distributive property works. Next I have identities. For identities, you're going to have an addition one and a multiplication one. So the identity for addition is 0. It says that for any number plus 0, I get that number. So I can add 0 to anything and it doesn't really affect it. The multiplication converse of that is 1. It says that a number times 1 is itself. So multiplying anything by 1 doesn't really do anything. And those are your identities. Number 9 is the additive inverse. Basically what the additive inverse is the number that you have to add in order to get 0. So A has the additive inverse. Inverse negative A. So like the additive inverse of 2 is negative 2. The additive inverse of 3 would be negative 3. The additive inverse of 5 is negative 5. The additive inverse of negative 1 is 1. The additive inverse of negative 5 is 5. So it's whatever number you have to add in order to get 0. We also have, lastly, the multiplicative inverse. So with the additive inverse, it was whatever you had to add to get 0. The multiplicative inverse is whatever you have to multiply by to get 1. So the multiplicative inverse, A has multiplicative inverse 1 over A. This is also called the reciprocal. So anytime you're looking at 1 over A, that's called the reciprocal. So this is the reciprocal. So for example, the inverse, and we're talking about multiplicative here, of 2 is what? Well, you do 1 divided by 2, so 1/2. The multiplicative inverse of, let's say, negative 3 is what? 1 over negative 3, so negative 1/3. So that's the multiplicative inverse. It's whatever number, so that when I multiply by it, I get 1. So 2 times 1/2 is 1. Negative 3 times negative 1/3 is 1. I could also say, what's the reciprocal of 2? The reciprocal of 2 is 1/2. What's the reciprocal of negative 3? The reciprocal of negative 3 is negative 1/3. These are the same question. So those are all the properties we're going to use for the real numbers.